Last week we already learned how to determine the region. Then from the optimal region we will determine the specific location for our facility using the gravity model. And in this phase, the managers will decide on the location and the capacity allocation for each facility. And also they determine how markets are allocated to the facility. So let me give you this example. We have 5 supply cities and 6 demand city. And this 5 supply city is from 2 company. Later I will give you which city belong to which company. And here, from here to here is the production and transportation cost per 1,000 units. So for example, from Baltimore to Atlanta, the production and transportation cost is $1,675 or $1,000. And here we have the monthly capacity of each location. So for example, the supplier in Baltimore, the capacity is 18,000 units. And to open a facility in Baltimore City, we need a fixed cost that is $7,650,000. And in this row is the monthly demand of the market J. So for example, 10,000 units is the monthly demand of the customer of the market in Atlanta. Or in Boston, the monthly demand is 8,000. Okay, so first you have to understand what we have. And we want to know how many products we should deliver from the supply city to the demand city. For example, how many products should we deliver from Baltimore to Atlanta, or from Baltimore to Boston, or from Baltimore to Chicago, so that we can minimize the total variable cost. Do you still remember that we have 2 types of cost? The first one is variable cost and the second one is fixed cost. Okay, the variable cost is the cost that are vary. It depends on the quantity they produce or they sell. But the fixed cost is fixed, is not vary. Okay, and here it's the same as the in phase 2, how the capacitated here. Capacitated plan location model, and we can use solver or Cplex or Lingo to solve this problem. So I will not teach you again because we already learned it carefully in the last lesson. So please use solver in Excel or Cplex or Lingo to solve this problem for me. And here is the solution that I use solver in Excel to solve it. So the same that we have the decision variable is this area, that is the quantity. The decision variable is the one that we want to determine, that is the quantity from the supply city, that like Baltimore to to the market Atlanta. Uh, and here is the quantity that from Baltimore to Boston. Okay, and we want to minimize this total cost. And we have two company, that is Telecom One and HiOptic. So Telecom One will take care of 3D city, so it means they have factory in 3D city, and in HiOptic they have the factory in 2D city. Okay. So here we try to allocate the demand to their production facility. We have n is the number of factory locations. So in this case, how many number of factory location we have? 5, right? And m is the number of market or the demand points. In this case, we have 6. Okay, here 5 here and 6 here. Okay, and DJ is the annual demand from the market J. So here is a DJ. For example, 10,000 is the monthly demand from Atlanta. And we also have the KI is the capacity of the factory I. So here is the KI. The capacity of the factory in Baltimore is 18,000. So K1 is equal to 18,000. And CIJ is the cost of producing and shipping from the uh, factory I to the market J. So we have Cij is here, so it's similar to the example we learned last week. So I would just talk quickly about this one, introduce quickly about this. And Xij, this one is the decision variable, the one we want to determine, that is the quantity shipped from the factory I to market J. And our objective function is we want to minimize the total variable cost. So the variable cost is equal to the cost of producing and shipping one unit from factory I to market J multiplied by the quantity we shift from factory I to market J. So, and I will run from 1 to n because we have n number and factory location, and J will run from 1 to m. M is the number of markets. That is our objective function. And we have some constraints, that is the total quantity shift from the factory I to market J has to be equal to the demand, the total demand in the market J, right? The total quantity shift to the market J has to be equal to the demand in market J. And the second constraint is the total quantity uh, the total quantity shift from factory I to all the market has to be less than or equal to the capacity of the factory I, because they cannot deliver more than what they have, right? So it has to be less than or equal to the capacity. Okay, so using solver you can find the optimal solution for this network. Please use solver or Cplex or Lingo to solve this one and compare with the solution I give you. And here is the homework for you guys to practice at home. And the deadline for this homework is noon Monday, next Monday. Okay, so it's 30. Let me check. So it will be 30 March, next Monday. So let me clarify the homework for you guys. Earlier we consider two companies, Telecom One and High Optic, and now they want to merge. They decide to merge these two companies into a single company called the Telecom Optic. And the Telecom, sorry, this one should be Telecom Optic because they already merge. So Telecom Optic will have 5 factories and they have to serve 6 markets. But the manager wonder if all 5 factories are needed. If they need to open 5 factories or they only need to open 4 or 3 factories. So first you have to determine how many factories they should open and where, in which supply city. And after that you assign the demand from 6 markets to the factories if you open that factory. If you don't open the factory, of course the demand assigned to factory is 0, right? And so that the telecom optic can minimize their total cost. So our objective function is minimize the total cost, and the information is given in the table. I will show you later. So please here write down the objective function constraint, and then you can use solver or Cplex or Lingo to find the solutions, and please send it to the assignment submission in Blackboard. And remember the deadline is next Monday, 30 March. And here, after merging two company, the uh, telecom telecom optic will have 5 factory here to serve 6 markets here. And here is the capacity, monthly capacity of each factory. And here is the fixed cost, monthly fixed cost of opening the factory in each city. And we also have the monthly demand for each market. So please write down objective function, constraints, and use solver in Excel or Lingo or Cplex to find the solution, then submit it to Blackboard. Okay. And next we will learn about the multi-echelon network design. And this one is very important and it's very popular for you guys to do your thesis related to this topic. So please pay attention and watch this one until you understand it, because it's really important for your thesis. So we have supplier. This is a supply chain, and I consider 4 elements in the supply chain: supplier, plants, this one may be factory, manufacturer, warehouse, and markets. In your thesis, maybe you can put more like distribution center, so on and so forth. And we have L supplier, we have N factory, we have T warehouse, and we have M customer. Okay, so it's like multi suppliers, multi plants, multi warehouse, and multi markets. And this whole network, we call it our multi-echelon network. So here we have capacity of suppliers is SH. H is the index of suppliers. So we have H will equal to Let me change another. Okay, H will run from 1 to L, right? And we have N factory, and Ki is the capacity of H factory. So K1 will be the capacity of the plant 1. So I will run from 1 to N because we have N factory. We have WE is the capacity of warehouse E, and E will run from 1 to T because we have total is T warehouse. And DJ is the total demand from the market J, and J will run from 1 to M. Okay, and we have FI is the fixed cost when we open a factory. FI is the fixed cost when we open factory I, and small FE is the fixed cost when we build a warehouse, when we build warehouse E. Okay, and we have CHI is the transportation cost from supply H to factory I, and CIE is the transportation cost from plant I to the warehouse E, and CEJ is the transportation cost from a warehouse to the warehouse E to the market J. Is transportation cost and plus the production cost as well. So what we want to determine? We want to determine the quantity we should. Okay, first we want to determine if we should open the factory I or not, and should we open the should we open the warehouse IE or not. So how many plants, how many factories should we open, and how many warehouse should we open. If we open the factory I, yi will equal to 1. And if we don't open the factory in location I, yi will equal to 0. It's the same with ye. So if we open a warehouse in location E, ye will equal to 1. And if we don't open a warehouse in location E, ye will equal to 0. So ye and yi is also decision variable, but it's binary variables. Okay, and we also want to determine the total quantity we are shift from supplier H to factory I. And we also want to determine how many products we should deliver from factory I to the warehouse E, and also the total quantity shift from the warehouse E to the market J. Okay, as you already clear about the objective, all the parameter input and the decision variable, and we want to determine those decision variables to minimize the total cost of this whole system, of this whole supply chain. Okay, so for more detail, for more information, you can read in the slide, but I already introduced to you about the inputs, parameter, and the decision variable. The objective function is we want to minimize the total cost, right? So the total cost is equal to the fixed cost plus the variable cost. So we have here, this is the fixed cost when we when we build the factory, and here is the fixed cost we have to pay when we build the warehouse E. And here is the production cost and uh, the transportation cost when we deliver products from supplier H to factory I. Here is the production and transportation cost from when we deliver products from the factory I to uh, warehouse E. And here is the cost of delivering products from warehouse E to the market J. Okay, so we can construct our objective function. And next we will have some constraint. The first one is here the first one is the total products shift from the supplier I to the from the supplier H to all the uh, factories cannot exist the capacity of the supplier H. Okay, second one is the amount shift out of the factory cannot exceed the quantity of raw material received. Okay, the constraint 3 is the amount produced in the factory cannot exceed its capacity, right? The constraint 4 that the amount shipped out of the warehouse cannot exceed the quantity received from the factory. Okay, the constraint 5 is the amount shipped through a warehouse cannot exceed its capacity, cannot exceed the warehouse capacity. Okay, and 6 is the total quantity delivered from the warehouse to the market J has to be equal to the demand of the market J. Okay, and we have the seventh constraint is the binary variable, that is yi and ye belong to 0 and 1, and all our decision variable is larger or equal to 0. And these are, if we have the data for this, we also can solve it by solver or or Cplex or Lingual. So maybe you guys can try to do the coding for this example. If you have any question, just feel free to ask me. I will correct it for you guys, because this part is very important for your thesis next year. So make sure that you understand it well. Also, we also can extend our model, consider the tax, tariff, or customer requirement because the main objective of a supply chain network is minimize the profit after the tariff and tax, while we also meet the customer service requirement. So that's why we modify our objective and constraint a little bit from minimize the total cost to maximize the profit. So RJ is the revenue they get after they uh, shift they deliver one unit of products so we have here is the total revenue and here is the total cost. So the total revenue minus the total cost, we will have their profit. So our main objective is uh, maximize the total profit. And here we can change the constraint a little bit, that is the total quantity shift from the supply I to market J less than or equal to uh, the demand in the market J, because we try to balance between the revenue and the cost. So this one don't need to be equal like the last example. It should be less than or equal to the demand. Okay. Okay, the last part in this lesson, that is we try uh, to make the network design decision in practice. So the manager should keep the following issues in mind when they make the network design decision in practice. So first, do not underestimate the lifespan of facility. The second one, do not gloss over the cultural implications. The third one, do not ignore the quality of life issues. And the last one is focus on tariff and tax intensives when locating the facility. Okay, so please do the homework and try to practice doing coding by yourself. Okay, thank you.